Thanks. Thanks, Corey. This is going to be a tough one. My voice left me a couple days ago, so it'll come and go as we go through this. But yeah, thanks very much for having me here. It's a pleasure to be with you all and share some of the work we've done on crows and ravens. Can you hear my voice back there? Yeah. Whoa. Okay. I'm going to talk about crows mostly first and then the raven work in Yellowstone second. But glad to take further questions on those items as well as we finish up. I like to start with this little video of a New Caledonia crow. You won't see a crow here do this, but they are pretty amazing animals. In New Caledonia, these birds make tools and use them to get resources that are out of their out of view and out of their reach. They use plant material, and here this captive New Caledonia crow is using a piece of wire to try to get food that's in a little bucket at the bottom of that tube. And that didn't work, trying to probe it like a spear, so she gets inventive. Makes a hook out of a material she's not familiar with and is able to retrieve the food snack. This bird wasn't trained to do this. This is what these birds do. They solve problems. The thing that I find interesting here is not so much the tool use, because we knew they used tools, but the manufacture of a unique tool to solve this new problem suggests there's insight involved. She understood the problem, had to have a hook to get the handle to pull that bucket up. So how do birds like this do this? There will be some graphs, there'll be some math, sorry. Hopefully you haven't had lunch yet, so you'll be able to stay with it. But this graph just shows the brain size of an animal against its body size. And as you might imagine, a bigger animal, whether it's a fish, a bird, or a mammal, has a bigger brain than a smaller animal. And these lines are the average relationship. So fish in general have smaller brains for their body size than do birds. And birds in general have smaller brains than do mammals. And within mammals, primates, like us, have the largest brains for their body size. But there's a lot of variation around these graphs. So for example, the ostrich is a bird, big bird, pretty small brain. And the crow and jay and New Caledonia crow are birds that are moderate size that have big brains for their body size. They're much more typical for mammals and even close to the line for primates. So for example, our American crow has a brain about the size you would expect for a small monkey. And in that respect, I think of these guys as flying monkeys rather than just flying birds. So they have brain power. They also have a lot of nerve cells, neurons, packed into that brain, much more than we do. And not in terms of total volume, but in terms of mammals. Birds have much more neurons packed into their small brains than mammals do. So they have got big brains for their body size, and they have relatively high numbers of nerve cells to make the connections that are important to remember things and feel things and solve problems like we just saw. They are also mostly social. So they live in groups, and like you all here are learning from one another and from me in this case, birds can do the same thing, social birds. So crows and ravens you often see in groups. They don't have to experience everything themselves to learn. They can learn by seeing what others are experiencing. And they live a long time. Crows and ravens, it's not unusual to have a bird that's in its teens. Certainly 20-year-old birds in the wild are not all that uncommon. So just to illustrate one of the advantages of having a big brain, one of my grad students, Loma Pendergraph, taught crows to pull up a string that had a chicken nugget hanging on the end of it. And crows will do just about anything for a chicken nugget. And then what they'd like to do is just fly down and grab it or break the string and take it. But if you coax them along, they will learn the difficult task of pulling up the string with their beak, stepping on it on the perch so that it doesn't fall back, and then pulling up the next loop and stepping on it, and next loop and stepping on it. And Loma had birds do that. And the birds that were fastest at doing it, fastest time, had the largest brains. consistently large brains. Those that were slow at it, some of them, the ones that were very slow up here, some of them had small brains, but even some of the small brain birds did really learn this task very quickly. So having a big brain can help, but it's not the end all to learn how to do some of these difficult tasks. Hang in there. There's a few slides that Corey said he was going to have a test on for everybody at the end. This will be the trivia next time. But I want to show you a little bit about how a bird brain works to do some of the things like we just saw. And the bottom line is it works just like yours does. It's organized differently, but we know it has centers for advanced learning and integration of sensory inputs, just like yours does, so that you can put things together that you hear and see or smell. And associate those with places or experiences and recall those later. Okay, they do that the same way you do it. For example, they bring in information from their ear through an auditory nerve that goes up to a part of the brain, field L, where they hear things and they can assess them. Is this a dangerous sound, a new sound? Maybe it's a sound of somebody opening a lunch bag. I'll go check that out. They bring in information from their eyes and also from their beak. Their beak is more like our hand. It's a very sensitive organ to touch and feel things. And like that New Caledonia crow sensing the mobility of that wire, that she could bend it, she was probably doing that with her beak initially. This was a flexible material. So they bring in information to different parts of the brain, touch up here, sight here, sound here. And then they make connections, actual connections among the nerve cells. The diagrams here, I should say, are from my colleague Tony Angel, who's an artist in Seattle. And what Tony has drawn here are nerve cells making connections, for example, ones that are in the area where sight information is being processed, making connections with those over in the hippocampus where spatial memory is stored, and then maybe perhaps out here in emotion. So maybe this was something that the bird saw at a particular place that was pleasurable. And by making this wired connection between those three areas of the brain, it has a circuit that it can call upon later to recall that place and that emotion associated with that sight. And you do the same thing all the time. You do one other thing that birds also can do, and you're probably doing this right now. You're probably thinking in your head, man, this is horrible. Why am I here listening to brain anatomy? Get me out of this room. The snow's not that bad. But you're considering that without sending that command to your muscles to get up and leave the room. At least I haven't seen anybody yet. And birds do the same thing. That's because they have a connection from their forebrain down through another part of the brain and back to the forebrain where they can loop information and they can assess it and they can refine it and they can change what they were going to do without doing it. So they can reconsider and make a different choice of what to do before they send that command down the brain stem and the nervous system to the muscles to actually carry out some action, to fly away or walk away, whatever it may be. So you can do that, and birds can do that. We think some reptiles may be able to do that, and we don't think amphibians at this point, that it hasn't been demonstrated that they can do that sort of reasoned adjustment of behaviors. So that's how bird brains work. You don't need to know anything more about them at this point. We'll go ahead and have some fun because they use these brains to do all kinds of weird things, like this raven at Canyon Visitor Center. Maybe. No. Just want to trigger that. Yep. Thank you.
Oh, one more time. Sorry, John.
Come on, Corey. I put this video on there, so this one should work. Well, that's a bummer because this is a cool video that Bob Landis took at Canyon Visitor Center of a raven this summer that was riding cars. And it would sit in the parking lot of the gas station there, and it would jump on a car. Car would take off. The bird would stay on the car and just ride it till it got to full speed out on the loop highway there. So they can have fun. The reason they do these things like this, maybe playing with a ball like a captive raven here had done in the Copenhagen Zoo, like your pet dog might do, or like this crow might have been doing with a string dragging in front of a cat that it lived with in a person's house, trying to get it to pounce on that string. They play like this because they get an endorphin release in their brain that rewards this behavior, just like yours. When you play, you get a charge out of it. You enjoy it. It's pleasurable. And those chemicals that reward your brain for pleasurable activities are the same chemicals that reward a bird's brain for doing these things. They're also delinquents. Yeah, I'm sure they've caused you heartache at times, maybe breaking into things they shouldn't have or stealing something out of your backpack. Crows and ravens around the world seem to be interested in anything we're interested in. They drink coffee. They take cigarettes. They have, unknown to us, lit up a cigarette, but they certainly take them. And actually, I always thought this was just kind of a weird habit they had. Maybe seeing anything we put in our mouth might suggest that it's a food item. But studies have shown recently that birds incorporate at least the filters from cigarettes into their nests often as a way to put an insecticide into their nest. So it might be even more adaptive than just a potential food item. They work as teams. Both crows and ravens mate for life, and they form these lifelong pair bonds, which are the strongest bond in any of their societies. Here, 2 ravens were described as poking a great horned owl with a stick. And we know they use tools to do other things like this as well, to move a predator along. They will work together to do these things. The raven's the largest songbird in the world, and the crow's not very far behind it. And that looping ability in their brain allows them, when they hear a sound, to shape what they're going to utter out in response to that. So given the neural ability to do this and make all sorts of noises, I'm sure many of you have heard strange sounds in the woods and gone on later to find it was a raven sounding like dripping water or a car screeching or whatever it might have been. But in Missoula, there was a crow that would go around neighborhoods and try to round up dogs. And a friend told me that he heard his dog barking in the backyard one morning, and he went out to calm his dog down. It was like 6 a.m, and up from behind the dog pops a crow saying, here boy, come on, let's go." In perfect English, better than me. And this crow was around Missoula for a couple of weeks, brought dogs to the oval here, would command them to sit or lie down, and then occasionally take off flying with dogs all chasing after him. And Tony and I speculated maybe this was a strategy again to get food, having this group of dogs run through students at class break, dropping a French fry or a bag of chips or something. Hung around for a few weeks and wasn't seen again. And we don't know if maybe it said one thing too many to a dog, but this has also now been confirmed with parrots talking to dogs and commanding them to lay and sit. So what's interesting, this was obviously somebody's pet. They raised it as a young crow, and they heard it talking to their dog a lot and picked up that voice and was able to use it to its advantage. That's what's interesting to me. It did something different than it had been trained to do or picked up on its own from the owner and used it to its advantage, out kind of rogue in this case. So crows and ravens have lived among us. They were here on earth before we were, and they've lived among us obviously since our existence, and very closely with us in the northern hemisphere for sure. During that time, they've influenced a lot of the ways we care for our food to keep them away from scavengers like the crows and ravens. So for example, here's a macaw fish drying rack in western Washington that has a scarecrow built into it. So while these people were worshiping the raven as a creator, they were also fighting it as the stealer and thief, stealing their food and trying to keep it away. In Norse mythology, ravens informed their god, Odin in this case, of what was going on each day. In Japan, artists drew great screens of crows to celebrate their social behavior and activities. So these birds have had a profound influence on us from day one. We were probably scavengers right with them initially, then we were predators that provided for them as well, and agriculturists. And they've influenced our thoughts and legends and dances and language. Think of all the references to crow and raven in the English language. There is no other animal, wild animal, that has influenced our language as much, because some of you are probably ravenous right now. It's getting close to lunchtime. We call this relationship where those birds have influenced our culture, and we in turn influence their culture, cultural coevolution. Just like a hummingbird and a corolla of a flower may have evolved to allow pollination and nectar extraction, the learned behaviors, the cultures of two species can also influence one another. And I think this happens a lot with crows and ravens. An example is shown here. This is a pot from the Mimbres culture in New Mexico. It's about 1,000-year-old culture. And shown in it is a trapper in the middle there holding some nooses and other nooses that he has put around this fence and hung crows from. And the little X's here represent a corn patch. And this trapper is trying to teach other crows to stay away from his corn. And that seems to be working, as some of these crows have left the area. And probably having seen the effigies hanging there and thinking this is a dangerous place. So while we were influencing the culture of these birds to stay away from particular crops, they were influencing our culture as being thought of as animals that might bring the rain or other important events in our calendar as well. So to do that, for those birds to be able to learn and to live with humans, which crows and ravens are experts at, it pays to recognize people, because people aren't all friendly with crows. Some of them are very friendly, like this woman who would feed crows every day in Seattle, and they would flock her car as soon as she drove into a parking lot. You probably don't want to park next to her car in the parking lot. And then there are guys like this that hunt crows. It's a legal activity in many states. And they line them up in weird patterns. And if you're a crow, you want to know this guy and be able to distinguish him from this woman. It could be literally a matter of life and death. So we've done experiments on this. I was supposed to. It's been a long day. Anyway, we did experiments on this by catching crows wearing this caveman mask. The way we catch our birds is to lure them into food and shoot a net over them. And when they're pinned down in that net, they're helpless. And I'm sure they think they're going to die at any minute. We take them out of that, we band them, we measure them, we let them go. We did that wearing this mask with 7 birds that we caught on our university campus. And then we'd walk around campus wearing this mask and the control mask. Dick Cheney, who was the vice president at the time we did this experiment, a Wyoming guy. He was a good guy. He didn't do anything wrong to the crows, but we wanted to have a control for the mask because that looks a little weird, right? So we walked around with both of these faces on, and we compared the crows' responses. Excuse me. What we saw before we did any trapping is the crows did not care about us wearing no mask, the Cheney mask, or the caveman mask with a hat, which is what we wore when we trapped. After trapping, they didn't care about us wearing no mask. They cared a little bit about Cheney. And they cared a lot about us wearing the caveman mask, whether it was just the mask, the hat, just the hat, or even the mask upside down, which is something that even young children have a hard time recognizing the face of their parents inverted. But the crows seemed to be responding. And by responding, what I mean is that they were scolding us. They were diving at us, chasing us, acting just like we were an eagle or a hawk in their territory, trying to push us out of their territory. And they kept doing this. So this experiment we started in 2006. We did a lot of replicates of it at that time because we wanted to make sure what we were seeing was true. And in fact, the amount of birds that were scolding us, treating us like a predator, increased over time. through about 10 years of our study. We'd go out once a year, and the moment I'd step out of my office, the crows would come and grab us and start scolding us. And this continued for 16 to 17 years pretty strongly, and then it dropped off pretty dramatically the last 2 years of the study. So why did this relationship hold so long? We demonstrated, I'm not going to show you those data, we demonstrated that it's part social learning and part individual memory. This bird in particular was one of the 7 birds we banded on our campus in 2006. She lived until 2022, and she scolded us every time she saw us with that mask on. And if I didn't have the mask on because I was teaching a class in the building right next to her territory, she never scolded us, never responded at all. She hated that caveman. That culture of hate was spread through the population from her kids learning, seeing her scold, other birds hearing the scolding vocalizations and coming in and seeing us being scolded and learning that it was that weird-looking guy with the caveman mask on that was being scolded. So let's dive a little deeper. Fortunately, at a place like University of Washington, we have all kinds of different scientists there, and I collaborated with neuroscientists to image the brains of crows as they were doing things like this. What we do, just to explain a little bit, we catch a bird, we put it in an aviary, and we take care of it. We feed it, we clean their cage. We wear one mask while we do that, and we wore a different mask. We got much better masks than the caveman going forward with these experiments. And so we had a dangerous face and a neutral or maybe positive face that these birds learned for a couple weeks in captivity. Then we would bring them over to the lab. We would give them an injection of a radioactive substance that mimics glucose. So where the brain and the rest of the body is calling for energy, this material goes there and it doesn't get processed. It stays there. It degrades in less than a day, but it stays there for a short period of time so that we could see what part of the body was involved as the crow was trying to do something, like in this case, looking out and seeing the dangerous face outside of their cage. Then we would anesthetize them and scan their brains using a PET imaging system, not an MRI, because you have to lay still. Anybody who's had an MRI knows it's a trying event. You have to stay completely still or the image will be blurry. So we had to knock our crows out to do that. But this drug that we gave them allowed us to peek back in time and see what was going on in their brain during the time that they were acting, looking out and seeing something. So what we did, here's an image of the bird's brain. And what you see here are the parts of the brain that are responding to sight, to information coming in from the eyes. This eye provides information to the right side of the brain and the right eye to the left side of the brain. The crow uses that information to assess something that it's seen. What you see in these images, you've probably seen things like this for human brains that show where in our brain, for example, our language center is or whatever it might be. These are statistical results that show the difference in one group of crows versus another group of crows. And the brighter the orange suggests there was more activity, more use of that part of the brain by one group than another group. And the two groups in this case are a group of crows that saw the person's face that caught them versus nobody in the room, just an empty lab. And the take-home message is that the amygdala on the right hemisphere of the crow's brain was activated when they looked out and saw the dangerous person, the person that they learned was dangerous, that it captured them. If you were to look at a picture or experience of something you learned was dangerous and your brain was scanned, your right hemisphere amygdala would also be activated. Exactly the same response as other vertebrates that have been tested, including humans and dogs now. In contrast, when they saw the person that had been cleaning their cage and taking care of them, the associative reward center was activated. That part of the Pavlov's dog's brain that was activated when the bell rang to indicate he was going to get fed soon was the same thing that went off in the crow's brain. So what about tool use? We started off with the idea about the New Caledonia crow, and I want to return to that with an experiment, again, that Loma Pendergraft did, a grad student in our lab. And Loma didn't train crows just to pull up chicken nuggets. He also trained them to drop stones in a tube of water to raise the level of the water so that they could get at a floating food item. And hopefully this video will work for you. So here's a bird trying to learn this task. Oh, can't quite reach the Cheeto. So it turns out that's a very difficult task to learn for American crows. Other birds can learn it maybe better. But American crows, we had 16 of them. Only 4 was able to do what you just saw that orange tagged bird do. So 4 of the 16. Some of you will not be surprised that the birds that learned how to do this were older females. They were adults. Females are smaller than males and crows and probably have to innovate more, was our thought, to solve problems like this. If you're a big crow, you just walk in and take whatever you need. But if you're not, you have to use your brains to solve these problems. So older females mastered this task. We were able to try to get a feel for what was going on inside the crow's brain while they were learning this task and executing it. And what we did is when we first caught our birds, we calmed them down for a few days. They tamed down very quickly. And we showed them that apparatus, the tube with water in it, a Cheeto floating, and some marbles alongside of it. And as they looked out and saw that, we were watching to see where that chemical we gave the birds, the radioactive tracer, ended up in their brain. And this is where it ended up. Basically what you see, unlike the image I showed you of the response to a dangerous face, there's a lot of bright orange in their brains. This is from the front to the middle to the back of the brain. And there's a lot of interest. They're actively engaged in looking at what the heck is this thing that's sitting in front of me. It's a very novel thing. It's got some food in it. Maybe that's interesting to them, but it's novel. So there's a lot of activity initially. We then trained the birds, like Loma just demonstrated, trained them to do the task, and we scanned them again after they were able to do it to some degree. And of the birds that never mastered it, they could maybe pick up the stones or maybe try to reach the food, but they never got the whole thing where they pick up stones, drop it enough to get the food. There was no difference in their brains when we scanned them. They looked just like this. The first time they'd ever seen it, they were still very interested in it, but they're like, I don't know what's going on here. But the birds that mastered it had one difference in their activity center. And that's this little piece right here of their brain called the tegmentum. That is also the part of the brain in the New Caledonia crow that is extremely enlarged. So it seems like this part of the brain, which is important in controlling motor activity, your movement, complex movement patterns, which you would have to use to make a tool like that hook, or to learn how to drop things in a tube of water to get food, is important in tool learning, in tool use. If we look at the 4 birds that were very accomplished at this task relative to those that weren't, we also saw some differences. So these are the differences in the high achievers versus low achievers. And there are 3 parts of the brain in the high achievers that were more active than the low. The hippocampus, what's called the basogastralis, and the cerebellum. So the hippocampus is what you use for spatial memory and remembering things, learning about your environment. The basogastralis is the part of the brain in a bird that works on touch coming in from the beak. And the cerebellum is important in memory, but also motor control. So what these crows are doing, these 4 birds that learned how to do this complex task, this tool task, they're basically like a ski runner at the top of a run, a slalom run, who you see go bobbing and weaving and kind of anticipating all the turns and ups and downs that they're going to have to do going through this complex task. They're like extreme athletes that have learned a task, and they're replaying it in their brain when they see the apparatus necessary to accomplish that task. They're going through, I remember this, I feel the touch from my beak, and I can control my body to move in the way that allows me to get that food. Okay, a little bit about compassion. Have any of you seen a crow funeral? No? Yeah, okay. Magpie funerals, same, yes. They gather around a dead animal. Magpies will even bury that animal. They'll put sticks and leaves and stuff on it. In this case, what Tony's drawn is a bunch of crows around a dead crow. They could be assessing who died. Is this a potential mating opportunity coming up or territory open? Is what's dangerous here? Why is it dangerous? Or maybe they're feeling sad about it. We investigated this a bit. Here's another example of a crow funeral. There was just one bird that brought in this piece of foil and laid it by this dead bird and stood there for 20 minutes. I would put money that that dead bird was that bird's mate, but I don't know. A woman sent me this image that she took. She was there the whole time, and pretty powerful feeling. So we tried to look again at what's going on in the brain of these birds when they look out and see a dead crow. Here's a taxidermy mount of a dead crow held by a person with a mask the birds have never seen. What's going on in their brain? This is the image I already showed you, the group of crows that saw the person that captured them. Their amygdala was activated. If we look at a group of crows that looked out and saw the novel person holding a dead crow, we don't see an amygdala. It's not a fear response, but instead it's a learning response. The hippocampus is again activated, and these birds are learning about a new danger in their area. So at least part of why these birds gather and have funerals around fallen colleagues is to learn about the danger that could be there. There may be lots of other things going on, but we don't know. I don't know if this one's going to run. Anybody want to put money on this? Yeah, I'm going to say no because it's the same. That's all right. Anybody from around here has probably seen wolves chase down a bull elk and kill it, and you often see ravens closely associated with that. So I'm going to transition to talk a bit about our raven work now. If you watch wolves, you almost always see a raven nearby, whether it's following them or flying in front of them or feeding at a kill. If you watch ravens, you don't always see wolves nearby because ravens are doing a lot of other things. This graph shows the food items that ravens ate. So we captured and tagged. We've done over 100 ravens in Yellowstone now, and 60 of them we initially had radio transmitters on that we could monitor their movements. What we see in the summertime is that anthropogenic foods are not used all that often. So things like agriculture or roadkills or gut piles from hunting, which doesn't occur much in the summer, are not a prime food source. But natural food sources, anthropogenic food sources in the winter are a prime food source. And again, those include gut piles, big time. They're out where any of you have been out elk hunting, you probably had ravens come in after you shot an elk. They go to the bison kills at the edge of the park. They hit wastewater treatment plants. I mean, if you really want to do something great, just go out to your dump here, and there's ravens all over, those of you who've been there. Some of our ravens have gone to that dump. So that's what they do in the winters. They eat human-provided foods, and in the summer, they eat natural foods. But the natural foods are rarely wolf kills or other carcasses. Instead, they're primarily insects. So ravens, you will see them walking in grassy areas, flipping over bison patties, or digging them for things, and they're getting insects as a prime food in the summer. They do have some association with wolves, but it's not nearly the extent that we thought when we started this study. So my colleague, Matthias Loretto in Vienna, is a movement ecologist specialist. So you can blame him for these graphs. I'll try to explain them to you. This line that you see here is 500 meters between a particular radio tagged raven we had and any radio tagged wolf in the park. So if you're above this line, for this is a territorial raven who actually breeds in the Lamar Valley. This is the average distance, or all the different times through from 2020 to 2022, the distance she was away from any tagged wolf in the park. Most of the time she was 1 to 100 kilometers away from any tagged wolf, all these points up here. Occasionally she was closer than 500 meters, which we assume is she's associated with that wolf, because there's some inaccuracy in our locations and the timing of our locations with the wolf locations. But sometimes she's very close. Here she was close to the Junction Butte pack. Here she was close to the Molly's pack. And here she's close to the Rescue Creek pack. So it's not always the same pack. She'll have her favorite pack, although the Junction Butte pack lives in her territory mostly. She'll go wherever there's a wolf. But she might be with the Mollies one day, and then she's 10 to 100 kilometers away from any wolf for the next several months. And then she's back by some wolves and then away, and then back and then away, and back and away. So she's not following wolves for her main strategy. She taps in, checks them out. If there's a kill, she'll stay with them and eat. Otherwise, she moves on to other things. So the vagrant birds, ravens, come in two forms: territorial breeders and vagrant non-breeders. That don't have a territory, they move around. They are free to go where they want to go. And those birds, the vagrants, tend to be more associated with wolves. There's a lot of points here for this individual. He went to 54 wolf kills during this 2-year period, and he was often close to wolves, associating with them. But here he is again. He's with the Junction Butte pack on this day, and then he's far away from any wolves for the rest, never another 2 months or so. So if these guys were closely associated in a symbiotic relationship with wolves, all the points would be down here. They would just sit with the wolf pack, follow them every place they go, and every 3 days or so when they make a kill, they would have a feast. Some of these vagrants do things that you really think, wow, they are keyed into these wolves. So here's an example. There was a wolf kill at this triangle, and on a day after the kill was made, nothing going to explode.
Not yet.
This individual flew in from the Billings dump over 100 miles, straight line, over the Absarokas, over the tallest peak in Montana, Granite, right into the kill, straight line. A day later, a bird from out by Bozeman did the same thing. I don't know what that is. But okay. Oh, okay, no problem. So this bird also flies in about 140 miles, circles around, comes into the kill. So we're wondering how in the heck these birds might have known of these kills. Did they smell something, hear something? Did the other birds who knew of it go back and roost with them and bring them in? All these things were possible. And as I'll tell you in a second, I don't think any of them are the actual explanation. So they do some amazing things in association with wolves that we wonder about. And to try to understand this a bit more, we need to know a little bit about what a raven requires. And basically what a raven needs every day is a quarter pounder. With cheese would be great, but it doesn't have to have the cheese. They need about that many calories per day for a bird of that size to meet its full requirements, which is why ravens spend a lot of time flying around and riding on cars and doing all kinds of other weird things, because they can get a quarter pound of food pretty quick. What we saw with the territorial birds is that they commuted out to anthropogenic food sources. So this was a bird who bred at Mud Volcano deep in the park. She would fly 50 kilometers one way to go exploit hunters just outside of Gardner, Montana, and the dump, and up the Paradise Valley at some of the other green boxes of trash that were there. And then she'd fly back and stay at her territory. And then she'd go back and forth and do that. So they key in on these anthropogenic foods and will commute long distances to get them. In contrast, they don't do that to wolf kills. So what we have here is the distance that a bird flew to a given kind of resource. And we have the territorial and the vagrant birds going to human resources. I just showed you a graph of those territorial birds flying a long distance. On average, they'll go about 12 kilometers one way to a dump, let's say, or to a hunter's kill. And vagrants, they fly less because they're always moving around and they just go to whatever's close to where they're at. But a territorial bird has to go back to its territory every night, even during the non-breeding season, to check in and defend it. In terms of wolf kills, territorial birds only fly on average 5 kilometers to a wolf kill. They fly 12 kilometers on average to an anthropogenic food source. So they'll take advantage of wolf kills that are near them, near their territory. They're always the first ones there at those kills, and they're dominant at those kills, so they can eat a lot. But they don't make a habit of it. The vagrants, on the other hand, fly a little bit more to those wolf kills, but pretty much the same as they would to a human resource or wolf kill. They're the same to them. And they're all, they take ones that are close by. So why would these territorial birds commute? It takes energy to do that, to go this 48-kilometer flight, which they do. They fly 48 kilometers per hour, so about 30 miles an hour. It takes 72 watts of energy. Think of a 100-watt light bulb. To repay that, the bird needs to get about 125 kilocalories of food. Not a lot. They get that with 3 teaspoons of fat or 4 ounces of bison. So when you fly out of the park from Mud Volcano, you go to the sewage treatment plant and you eat fat because it floats on the water and it blows with the wind to the side of the settling ponds. And you'll see ravens on the edge of those settling ponds eating fat. They only need 3 teaspoons, and they repaid their full commuting costs. Or you go to where the bison have been hunted outside the park, and you get a few mouthfuls of bison, and you've repaid that cost. So it's a pretty easy thing to repay, in my view. In contrast, if you hang around wolves, it's dangerous. They chase you. There's a lot of other animals there trying to get the food too. You're vulnerable on the ground. By these kills where there's eagles that come in, they will just as soon kill you as look at you. And they're not as predictable. The sewage treatment plant's always there outside of Gardner, but a wolf kill is not. And at a wolf kill, you see things like this. So this is just the number of birds at a kill. The kill was made here. There were 4 ravens around when they made this kill. And that increased to about 15 ravens that they were going to have to compete with over that first day. By the next day, there were 23 or up to 30 ravens there later in that day that you had to compete with for this limited, tight resource. Plus, there were foxes and magpies and eagles and wolves up until the first 2 days. So most of the food is eaten by wolves. They provide some for these scavengers. Obviously, that's an important thing. But it's not just this is a great bounty that I'll go and eat. I've got to work for it there. And I think a lot of the reason ravens go to these kills is not so much for the food, but it's for the other ravens. They go there to interact socially with them. And what you see at a wolf kill is ravens displaying all sorts of dominant status to one another, looking for a potential mate, emphasizing this is my territory, stay the heck out. Unless there's a kill here, you can have some now, but don't come back in the breeding season. So how do those long distance flights occur? Our hypothesis is that it's a behavior we're calling checking in. And basically, those birds would come in from Billings or from Bozeman. They'll fly through the Lamar Valley. And if there's a wolf kill, they'll drop in there. So they know where they're going. They're going to areas that have the highest probability of having a wolf kill, which is that northern range, the Lamar on up through Blacktail Plateau. The birds come in, they check that area. If there isn't anything, they keep going. They might settle with some other ravens at a road kill, or if nothing else, they'll go to the dump, and they'll repay their energetics of doing that pretty quickly there. So they have great command of huge areas, hundreds, thousands of square miles. And they know where the resources are and the timing of those resources at those places. And most of what they know at that time is what we're doing. and where we're at and where we're providing food. And now, okay, wolves are too, and they've learned that, and they go and check those areas routinely. Maybe for social interaction, but also for feeding. But they're really keyed in on people. And as I said, they've been keyed in on us forever from their standpoint. This is a Pleistocene scene with ravens feeding with dire wolves probably, but there were gray wolves around at that point as well they were interacting with. There were people starting to come into these scenes for the last maybe almost 1 million years, and they interacted with us then. So they are smart. They've shared this long social and cultural history, developed this cultural coevolution with us over this time, and that continues to affect us to this day. So a lot of times crows and ravens get to be annoying. Maybe they're a challenge for a species we also like a sage grouse, for example. And they're killed by the tens of thousands every year to reduce their impact, or we think they might reduce their impact on things like sage grouse. I would say before we pull the trigger on an animal like this, we should understand and celebrate our coevolutionary relationship with it. Think about why they're there. Why are they affecting sage grouse? Move the resources that are attracting the birds there. It could be a water treatment plant. That's why they're going there. Oh, there's a sage grouse on the way. Okay, I'll drop in and eat some sage grouse chicks. So think about the whole pattern, the whole process, and take that into account before we just try to kill as many of these animals as we can. With that, I would thank you for putting up with my voice and the speaker, and I'm glad to answer some questions if you have them as well.